Workplaces like factories or fulfillment centres are filled with many moving parts and require constant supervision and alertness to ensure worker safety. But what happens when errors or accidents happen unexpectedly? On the simplest level, it creates chaos and can impact productivity. On a larger scale, it can create a dangerous environment for employees. How can technology, like AI and the creation of a digital twin, help quickly correct errors and prevent accidents before they occur? And could these virtual replications of a physical space ensure workers go home to their families safe and sound? Join us as we learn more about the world of digital twins and the many ways they can not only improve workplace safety, but also public safety. Welcome to Technically Speaking, an Intel podcast, the show that brings you the stories and insights of AI, presented by iHeartMedia's Ruby Studio and Intel. Hey there, I'm Graham Class. Today, we're exploring the spaces and places replicated by digital twins. For starters, what is a digital twin? We're going to be examining digital spaces that represent an actual physical space in our world. To discuss the topic further, we're joined by Tony Franklin. Tony Franklin is the General Manager of the Federal and Aerospace Markets, which includes military, aerospace, and government within the Network and Edge Group. He has more than 20 years of corporate, entrepreneurial, business development, and management experience, focusing on starting and growing multiple businesses that apply to the Internet of Things, intelligent systems, and communications technologies. Intel's Network and Edge Group provides solutions that lead the industry in transforming businesses and the way we live by making it simple to create exciting new IoT solutions. Welcome to the show, Tony.
Thank you. Glad to be here.
We've seen a lot of science fiction depictions of digital twins over the years in movies and films. The one that comes to mind is The Matrix, where the entire world is a digital twin, although it's used for sinister motives. I'd like to get your definition of what a digital twin is.
Yeah, sure. It's interesting you said The Matrix. I had to laugh because of all the examples we've joked about. That's one that hasn't come up. And it's so obvious when you said it. I'll start to use that. In its simplest form, for me, a digital twin is the digital replica of the real world.
And in terms of the technologies that are out there needed for digital twinning, maybe you could describe a little bit of how those sorts of systems are put together and what are some of the technology that Intel has that can help that.
Yeah, sure. It's really been an evolution of technologies that some of them we're all used to using, and some of them, if you're not in the field, maybe not so much. And so Gartner, one of the well-known analysts, has this emerging technologies trending chart they do every year. And they talk about edge AI, so artificial intelligence at the edge, the place where data is actually being generated more so than in, say, the cloud or data centers. That's happening. It continues to evolve. It's growing more and more. We're pushing more and more intelligence to the edge. And by the edge, it could be everything from a cell phone, a refrigerator, a car. Again, where is the data actually being generated? And then they talk about digital twins being sort of the now to 3 years. I think one of their data points was something like 40% of businesses, large businesses in particular, plan to use digital twins over the next 2 to 3 years to actually generate revenue. So that's happening now. And then lastly, over the next maybe 6+ years, they talk about the metaverse. Now, while we don't generally talk about the metaverse as much, the name means different things to different people, but it's the full extent of how does commerce and any other business really leverage a fully digital space that has interaction with the real world. So there's this spectrum that has been happening between sensors, with cameras being the most obvious, because we're all using cameras today. Our phones have so many sensors, we take them for granted. But all the sensors, one of the key technologies that are needed, an ability to replicate, if you're doing visual digital twin, so an ability to replicate the real world. And of course, physics modeling, if you're really doing analysis and you need to replicate the physical asset in a digital world. So computing capability to be able to replicate the behavior of the object, with AI being a critical component to now actually apply intelligence and analysis to the twin. So when you think about those different areas, well, Intel, we don't make sensors. Everything else along the way is where we tend to play. Clearly, computing technology, the ability to apply AI, so both from the software side and the various different computing technologies that enable AI, whether it's processors or GPUs or AI accelerators, et cetera. And then, of course, we have a very broad, really world-class partnership and ecosystem that we work with to enable the different industries.
Okay. And in terms of trying to get like a visual kind of representation of what this would look like. So say if you're walking in a warehouse, for example, and you're looking at the shelves around you, you might see some conveyor belts. How would it actually look in a digital twin?
It depends on the use case. The simplest version I'd use that many people should be able to relate to, obviously many people can relate to Matrix, but from an application standpoint, I would say think about Google Earth.
Yep.
Or Google Maps even. That is a type of model, right? Another example is many of the retail applications allow you to basically embed their items that are for sale into the digital replication of your particular space. So it's a real world and digital combination. That's always the key. So those are very basic, simple applications that people use and don't even realize. They don't think about them as digital twins, but they're already getting used to this relationship between the real world and the digital world.
Yes, I saw Intel has a software platform called Scenescape that can transform data from this world of sensors to create a real-time digital twin of your physical space. Can you tell me a little bit more of how that works?
So there's really three basic steps. One is mapping your space. The key, though, in the type of real-time digital twinning that we pursue is it is a coordinate accurate space. So it's not just taking a random space. We know that that room is 20 feet by 25 feet. And we also know that the cameras are 6 feet up on the wall. We know the actual XYZ of the space. So that's the first step.
Mm-hmm.
Second step is calibrate the space. So calibrate meaning I have the space. Where are my sensors? So my sensor is 10 feet up, 4 feet over in that corner, et cetera. Now, you turn on your sensors and you ingest that into Scenescape. Notice I haven't actually visualized necessarily anything. So the key for people to realize in real-time digital twinning, there are some applications where someone's not actually going to be sitting there watching the digital twin of the store. They don't need to do that real time. The AI and computing, obviously the AI tools and the actual AI models, the inferencing capability of Scenescape is doing the work. You are configuring it so you could add things like heat maps or tripwires so that you can actually have events based on whatever policy you want to implement so that you don't have to actually monitor. So I'll know that over in this area of the meat department, if there's more than 20 people for 20 seconds, there's something that happens. I don't even have to watch anything for that. The intelligence is making it happen.
Gotcha.
Now, if what I want to do later is now hit the rewind button, the founder and creator of this particular product, he has a phrase I'd love to use. It's called the DVR for the real world. AI is happening real time, but if you want additional analysis afterwards, you have that capability.
I can imagine there's a lot of challenges trying to come up with these digital twins. What are some of the top challenges or issues that people who are looking to try and deploy these sorts of systems would have to consider?
The most prominent one, to be honest with you, is the mindset. More than anything technical. You think about some of the technology that's growing in our own homes, Siri, Alexa, our cars. There's so much technology, and most people really don't understand. You're already using AI. In many cases, you're already using some sort of digital twin technology. There was one demo we had for Scenescape, and the executive loved it. It's like, this is amazing. I can do motion tracking. I see where people are. I can have multiple cameras monitoring the same asset or person or object, but I only see one, so it deduplicates the person. I can track if somebody's been in a space. Maybe I have a radiation sensor, and I can actually track how long that person has been in the space, and I can set triggers. There's so much he saw that can be done, and he was so excited. And he said, where's the AI?
Right.
Well, it's the AI that's doing everything you just described.
Yeah, that's right.
You just like, and it actually set us back for a second. We're like, well, clearly We need to make sure we understand where people are starting from. We can't assume they already know there's a level of technology and integration of that technology.
And that's one of the biggest challenges when it comes to understanding digital twin technology. It's the messaging. Some of the very tools that you're accustomed to right now, like the cell phone or the smart speaker that you're listening to this podcast with, are essential when we consider the future of digital twinning. So when it comes to a future that incorporates AI into our daily lives, we've actually already taken the first steps down that path. One of the things I like to examine is the way that technology actually helps democratize, and maybe you have some sense of the type of customers. Are they sort of large enterprises? Because I'm really keen to see this sorts of technology really get pushed down to the smaller businesses, and make it affordable for them to adopt and use. Do you have any thoughts about that particular trend?
Yeah, absolutely. I'd say they're all generally larger enterprises, but they may be larger enterprises with smaller facilities. So they have to think about the implementation at the store level, and then they can step back and look at it at an operational level for the entire business that they're trying to run. When you think about physical security, well, physical security can happen on a construction site. It can happen in an office space. It can happen anywhere. But the companies we're dealing with are generally the companies that, one, have the actual technology, so they may be the camera vendors, et cetera, but where it's actually being implemented, they're targeting a broad range in particular segments, like I mentioned, but the actual implementation may happen at a different level. So it's the companies that apply technology across specific segments, and then they actually, tier those down. Cities can be large or they can be smaller, but you're implementing generally starting at an intersection level. So that could be maybe 4 cameras max, but now I've got 1,000 intersections.
Mm-hmm.
So it grows and scales. And what we're seeing, back to that early adopter, we see the big picture. Let's start with 3 intersections and let's see and understand where technology can be applied there. Because one of the ways I like to explain to people, you need to understand the environment, the scene. That's why it's called Scenescape. The scene, the area, your environment better. That's one way to think about digital twin being able to enable that.
Do you have any other examples of benefits that your customers have seen, whether it be productivity, increased revenue, better safety?
Yeah, I'll go in reverse since you said safety last, because that's one that is so common to people. In fact, I think it was the university in Texas that is doing some pilots with the cities and with smart vehicles. And it's a device called a roadside unit. Again, most people don't even realize it. You pull up to an intersection, there's normally a smaller box on the side. You already have the box that controls the lights, etc. Well, I want to do more. So you can make that unit more intelligent. You can actually allow that roadside unit to communicate with cars as cars become more intelligent. They have 5G, they have wireless communication. So they implemented a pilot where there was a particular intersection. So as the car pulls up, imagine an alley off to the left. So the car can't see down the alley clearly, but there's a pole on the right that has a camera. The camera can see the car coming. The camera can see down the alley. The camera has a roadside unit with Intel processing equipment. It's running Scenescape. Again, they don't even need to visualize this. The camera sees someone walking down the alley. The car is coming forward. It can communicate to the car, because even the cars with the cameras can't see around corners. So the camera can communicate, there is somebody walking, you need to slow down. Knowing the speed of the car is great. Acceleration, we understand that. But knowing where that car is at, the speed of a car coming down a highway is one thing. The speed of a car coming down that street where there's an alley is a totally different scenario. I need to know the location of that car relative to the camera and relative to the person around the corner, both coming at the same time. So 3D is also a key aspect and value of digital twin that translates to end benefit like you're talking about. So that's safety right there. And that safety translates to insurance as an example.
Yeah, just feeding off that safety theme, can technologies like Scenescape and having those sort of cameras help with worker safety, say in a factory or a warehouse, where they can detect or even predict, if something's going to go wrong and actually warn a worker that something's going to happen?
Yeah, absolutely. Robot interaction is a common one also. So think about robots with cameras and the cameras and sensors that are around. Mobile World Congress is going on right now. And I think it was last year did a Scenescape demo there, and it was purely an industrial. We had the robotic arms that were moving and they were building something. And then you have a sensor, doesn't even need to be a camera, that has a digital in Scenescape, the tripwire. So we know if somebody crosses this point, then it's a tripwire. So that was the actual demo. So there was a safety zone, and then there was crossing the safety zone. So if you enter the safety zone, there could be a warning light to go off. You don't have to stop anything, but I know someone's in the safety zone. I know how long they've been in the safety zone. And if they cross past that, then I know I can start to shut down automatically equipment if that's the policy that that particular site chooses to use, or they can execute. And another one in a more constrained environment warehouse that we've seen is where there's actually controlled space. So radiation, actually, the earlier example I talked about is a real example where there's an area that it needs to be climate controlled, and it literally has radiation. So they have a radiation sensor both inside, outside, and can monitor. Do you have the equipment on? How long has a person been in this particular space? And I could set timers and triggers so I know that they can only be in for so long. And I can also track that. So that's real-time action and control. And I can also use that for later analysis and prediction. Maybe I need to change the configuration of the room. Maybe I need to put more signs up. But you can have real-time action and decisions and also post-analysis.
Yeah, what you said there about the simulation is quite interesting because, as you're talking, I was, going back to the gaming side of things, playing SimCity or Roller Coaster Tycoon, being able to sort of simulate, if I put this thing here, is it going to be dangerous? If I put that over there, does that help the workers? Does that help with productivity? Maybe talk a little bit of some examples of using real-world data to kind of do what-if analysis of various scenarios that management and workers together can simulate and potentially improve the workplace.
So let's take something like a gaming site. Like a football or soccer. So clearly those are massive events with a lot of people, a lot of entrances. There's safety concerns. There's access to medical professionals that need to get in and out. So can I take existing data that has already been captured using existing cameras, and I can actually run simulations on that? I could also, ideally what I want, and I need it if I'm going to do a digital twin, I need some sort of digital twin of the environment. The level of depth is just depending upon the level of analysis that you want to conduct. Now what I need is what's the data that I've been able to collect? Because most of these places, they're already going to have some data. Even if it's just camera feed data, I could take that and actually start to run models on, okay, where are people congregating? I can actually post camera feed and apply inference data to that.
Mm-hmm.
So I can use the AI to identify, well, that's a person and that's an animal, or that's a car over there. And now I can start to look at, okay, how often are they in these spaces? Where am I getting congregation? Where am I getting long queuing lines? So I can do analysis all on existing data. Now I can start to reconfigure whatever actions need to be taken. So all of that can happen before I've shown up physically at the space.
Just think about all the personal, identifiable information involved in some of the tasks we're talking about today, or the sheer amount of streaming data coming in from a host of sensors required to implement digital twinning. Keeping that data secure is paramount to the future of this industry. I'd like to get your thoughts around the whole privacy side of things and, what can be done to make sure that as individuals, we don't feel like our privacy is getting invaded.
Well, that's a very good topic, and we thought about that from the beginning. So one of the ways that we've defined Scenescape is we primarily work on metadata. And what metadata simply means is, for instance, we don't do any facial recognition. I need to know that that's a person, or I need to know, in fact, we had an actual scenario where a customer had a particular area and they knew people were around, but at night there were objects and they didn't know what it was. They were animals and the model hadn't been trained for animals. So the model can say, hey, there's something there. I can't say that it's a deer versus a whatever, but it's not a human. And so think about the simplicity of that. Now I don't have to transmit every movement, every aspect. I'm only transmitting what's critical to make the decisions that are needed real time and for post-analysis.
We talked a little bit about fulfillment centers and warehouses. I, like everyone else, use e-commerce sites like Amazon Prime. I'm just wondering if you could maybe paint a picture of how, from the time that I hit that buy now button to the time that I get my pair of socks at my doorstep. Perhaps take me through how digital twins could be used. How would a system help that process, both as an end consumer and also for the business?
Actually, to be honest, one of the first examples that came to mind is the delivery truck and why location intelligence is so important. All of us use location-based services today. There was a study I read, I think it was UPS, is saving a lot of money per truck because they realized the location intelligence they were getting, more particularly, this was when hotels were putting in their addresses because they use Amazon Prime too, and they're getting these packages shipped to them.
Yep.
The location data of that hotel relative to where the truck is coming from and then mapping the route were not good routes. So it was costing the company so much money to get from point A to point B. So now I can start to identify where are the hotel. And they discovered this and they started taking copies, which they have this with Google. You can take copies of the maps. I can start to locate where am I going. I can start to figure out the routes. So they're using the twin of the maps and the data they already have. Think about it. They have tons of data on their routes and the locations and where are they normally congregating and which truck should they send? What time should they be? They did all of that analysis to figure out just on the back end of when I actually drop the packets off to you and what makes sense. That's saving money for them completely. And again, it's location-based.
Yep. And can you give me an example of how digital twinning might already be in use for the consumer on one of these sites, such as Amazon Prime or similar?
I have a chair behind me I just bought. So now I can use digital twinning right now to figure out exactly where I want this. How does it look? And they also have those clothing services, which are digital twinning. You're the real person, and they have the digital where you can apply the clothes to you.
Yes.
I mean, again, these are services that people are using today, but back to my earlier comment, you're not actually thinking about the technology or taking that now back to work, to your day job. Oh, I do all of this at home. I should be applying this to my business and saving money and getting greater insights of my scene and of my environment. So those are a couple of examples. Can I give you a different example?
Sure.
Most people have some sort of Ring doorbell or type of, it could be Ring, it could be Simply Safe, whatever.
Yep, I have that.
There you go.
Yep.
One of the ways we've gone to market is to make sure what we're doing is standard-based and open, maximum scalability and flexibility. So I have a Ring, one of my family members has Simply Safe. The challenge is I have the Ring camera at the door, I have another Ring camera, I can connect them. I can see if something's walking by. That's great. It's not very open. I'm somewhat siloed. What we've had someone do with Scenescape is they use Scenescape. First of all, they don't need to go to the cloud, so they're not paying anybody.
Okay.
If you want to use the cloud, you can, but you do not have to use the cloud. Everything can be edge-based. And by edge-based, think about the edge again. At home, where's the data generated? That's my edge. So in this case, your edge is your home. So in my home, I already have a computer. And I already have one or two cameras, but there's a particular type of camera I want for the front yard, which is totally different than the camera I want indoors, which is totally different than the camera I want. So 3 totally different brands. Well, it's called multi-camera, multi-brand from that sense. So,
Gotcha.
And by the way, maybe I want a heat sensor or something like in a particular area in the backyard because I want to know if there's something overheating. So now I can add all different type of brand sensors and I can connect that into Scenescape. And now Scenescape already has AI. So I've used different brands. I've used my own computer. So I have standard-based connectivity. And because of standard-based connectivity, I can connect it to my phone. Every phone app now, it's very easy to connect to and get alerts. So now I can start to use the existing AI tools that are in Scenescape, but there are so many applications out there with Scenescape, you can integrate it with other applications. So there was one person that used it to identify the difference between a car coming in the driveway versus a postal truck that goes by and stops. And they set an alert so whenever the postal truck comes and stops for a few minutes, the alert goes on the phone. He never has to look at a camera. He knows when he gets that alert, mail's here. You can't do that with Ring. You can't do that with these other applications. So that's a common use case that people know today where standard digital twinning technology with AI, standard-based communication, and standard computing technologies can all be used to enable use cases that we use every day.
Yep. We just have time for one more question. I would like to get your number one, I guess, area of excitement for digital twins?
For me, it's healthcare. What I want to see in my lifetime, and we have the technology to do it. In fact, we've have a few use cases with Scenescape where we're working with the medical community. I want the digital twin of my health. I want, for me, the person, think about all the data, all the medical records. First of all, it's hard enough keeping all your medical records together.
Yes.
So not only my medical records, but the medications I've taken, any reactions I've had. You have so much data from blood work and positive reactions, negative reactions to medications, exercises I've done that may have improved weight or blood pressure. So as I grow and as all of us grow and age, I should say,
yes,
I want all of that history to follow my DNA, my person, to maximize healthcare. I am the ultimate digital twin that I want. I don't care about an avatar. That's fun and fancy. I want something that helps and improves my quality of life.
Yeah.
That's what I want.
Out of interest, have you seen any companies or businesses looking into this?
I did meet a company or CEO of a company that's working on the medical record side, where they're trying to tie all of that to the person so that can follow them, so that now physicians and healthcare workers can have all that. So it's a startup. It seems to be much more challenging to get this done than you think it would be. But we've engaged with some companies and hospitals that are making their hospitals smart. You can see some areas called the smart operating room.
Okay.
That's a particular area in a hospital that's obviously critical. I mean, you think about something as basic as we're in the operating room, we're starting the operation. I have 12 high-value instruments on my right. Those 12 high-value instruments need to be there when I finish, because if they're not there, there's a very bad place they could be.
Yeah, that's right.
And that is a real example that I know personally somebody like that's happened to, and they've had to go back and get one of those instruments. Yeah. So when you think about the seriousness of the operating room, and that's before you even get into intrusive sensors and, I mean, what's the blood pressure and et cetera.
Yes.
You never go to a hospital or to a healthcare professional and they take your blood pressure and that's it and you're good. Then they start talking to you. No, we don't even think about the fact that we take blood pressure, we take temperature, we take weight, sometimes we take blood. So we're already experiencing a multimodal environment to maximize our health. But we don't always think about that when we bring that to work. So no, I need a temperature sensor. I need light. I need LiDAR. I need cameras. I need different brands. I need to apply intelligence to that. So now I can perceive my space and my environment. I can understand it with analysis and AI and make sense of it to make decisions. And then I can also do prediction based on that. So what should happen in the future?
That's great, Tony. I think we'll leave it on that note. Thanks so much.
No, thank you. This was fun. Really enjoyed it.
My deepest thanks to Tony Franklin for sharing his expertise with us. Today's chat about digital twins really opened my eyes to their incredible potential. It's like stepping into a simulation game where you can tweak maintenance schedules, production lines, and even play around with the interaction between workers and machinery using real-world data. Yes, I'm letting my inner geek shine through here, but the idea of managing a supply chain with the ease of playing SimCity seems pretty cool to me. Tony's closing thoughts on the future of healthcare and the possibility of creating a human digital twin were particularly striking. Imagine having a clone of yourself, in a sense. I mean, we're already wearing watches that monitor heart rate, physical activity, sleep quality, plus a range of other biometric data. It's not too far-fetched to dream about a future where digital twins can forecast our health outcomes based on our DNA, diet, and exercise. It's an interesting idea, and I'm looking forward to seeing where this technology takes us. And lucky for us, we'll get a chance to explore this further on our next episode, Tuesday, April 23rd, on Technically Speaking, an Intel podcast. We'll be learning about some of the revolutionary implementations of AI in the healthcare space with team members from Intel and Siemens Healthineers. See you then. Technically Speaking was produced by Ruby Studio from iHeartRadio in partnership with Intel and hosted by me, Graham Class. Our executive producer is Molly Sosha. Our EP of post-production is James Foster. And our supervising producer is Nakia Swinton. This episode was edited by Sierra Spreen and was written by Molly Sosha and Nick Fershaw.